The inventor of the Ka-52 armed helicopter is truly a genius. Even if its tail is hit by a missile, it can still continue to fly. This is mainly due to its unique coaxial counter-rotating twin rotor design. Conventional helicopters produce a reactionary torque when their propellers rotate, causing the aircraft to turn in the opposite direction of the propeller. This is why a small propeller is installed on the tail to provide counter-torque to balance the aircraft. However, if it gets damaged, the entire aircraft would crash immediately. The Ka-52 doesn't face this problem. It has two propellers on its main shaft, rotating in opposite directions. They are connected through gears and a drive shaft. Driven by the green drive shaft, the blue gear rotates the upper propeller clockwise, while the red gear rotates the lower propeller counter-clockwise. The torques from the two opposite rotating propellers cancel each other out. Even without a tail rotor, the Ka-52 can remain stable in the air and fly at a maximum speed of 300 km/h. Its rate of climb per second is much higher than that of the American Apache armed helicopter. This is mainly powered by the two TV3-1117 turboshaft engines mounted on the fuselage, which can generate 5,000 horsepower. The four fuel tanks in its belly provide a range of 1,200 kilometers. The Ka-52 has another unique feature. It's the only helicopter in the world with ejection seats. Pay attention. Once the ejection switch is pressed, the propellers above the fuselage and the cockpit canopy are blasted off first. Then, the rocket launcher on the seat is activated, instantly ejecting the two pilots. The electronic targeting system mounted on the nose can clearly scout the battlefield environment day or night. The millimeter wave radar on the nose has a maximum detection range of 32 kilometers, capable of detecting ground targets within 25 kilometers and aerial targets within 15 kilometers. On the left side of the Ka-52's fuselage is a 30mm caliber cannon with a magazine capacity of 280 rounds and a maximum range of 4 kilometers. However, its firing angle is very limited and cannot achieve 180-degree firing like the Apache. The Ka-52 has a total of 6 weapon mounting points. Each rocket launcher can carry 20 rockets, capable of easily destroying enemy positions with a full salvo. It can also carry the 9M120 anti-tank missile, which can penetrate tank armor up to 800mm thick from 6 kilometers away. The IGLAS portable anti-aircraft missile mounted on the fuselage can also destroy aerial targets within 6 kilometers. How do astronauts safely return to Earth from the space station, and what thrilling experiences do they go through? First, they complete the handover of work with their colleagues who will continue to stay on the space station. Then, they enter the return capsule and close all hatches. Subsequently, they release the docking clamps, allowing the return spacecraft to detach from the space station. At this point, the spacecraft gradually moves away from the space station. Once the distance is sufficient, the spacecraft ignites its thrusters and braking engines to reduce its velocity, gradually lowering its orbit to smoothly enter the descent path in the Earth's atmosphere. This is the deorbiting process. As the spacecraft prepares to enter the Earth's atmosphere, it rotates 90 degrees to ensure that its components won't collide upon separation. Then it separates into 3 parts: the propulsion module, the orbital module, and the return module. The orbital module contains waste generated by astronauts in space, and it, along with the propulsion module, burns up upon re-entry into the atmosphere. The bottom of the return module is equipped with special heat-resistant materials designed to withstand temperatures between 1,000 to 2,000 degrees Celsius caused by the friction with the atmosphere. This ensures that astronauts are not harmed by the high temperatures experienced during re-entry. As the spacecraft travels through the Earth's atmosphere, it encounters intense friction, which ignites a high-temperature flame reaching 1,000 to 2,000 degrees Celsius around the outside of the capsule, forming a plasma barrier that can disrupt radio signals. During this phase, astronauts temporarily lose communication with the ground control center for about 5 minutes, entering what is known as the blackout zone. astronauts must endure significant psychological pressure during this phase, which is beyond what an average person can handle. Additionally, they must adapt to the abrupt return to gravity after working in a weightless environment for an extended period, which may result in discomfort. When the return capsule is approximately 10 kilometers above the ground, the parachute cover opens automatically, followed by the sequential deployment of 4 different parachutes to slow the descent. The heat shield at the bottom of the capsule separates to expose the landing engines. As the capsule continues to descend, at about 1 meter above the ground, the retro rockets are ignited to assist in achieving a safe landing. Once on the ground, the heroes inside the capsule need only await the arrival of ground search and rescue personnel. Pay attention. When the airplane's tires are worn to this extent, they need to be replaced. Changing an airplane tire is quite similar to changing a car tire. However, there are more details to be aware of. Let's learn how to change an airplane tire together. A Boeing 747 has 18 tires. Each tire costs about $5,000. After about every 150 flights, the tires need to be replaced. When the airplane is brought to the maintenance pad, the mechanics will check the wear of each tire. Tires worn to this extent need replacement. They usually bring 2 new tires to the site. After removing the transportation protective shell from the new tire, the tire pressure must be checked first. If the pressure is not sufficient, nitrogen will be added until the pressure reaches 220 psi, which is 6 times that of a car tire. When changing the tire, the airplane has to be lifted. A jack is used, but this jack is called a pneumatic hydraulic jack. It has a hose connected to the tire valve to provide power to the jack using the tire's pressure. The airplane is raised little by little, but it can't be raised too high, or the plane will tip over. Lifting it about 3 centimeters off the ground is enough. Before removing the tire, the nut protective cover of the tire has to be removed. It protects the center nut and pressure sensor of the tire. Then remove the safety screws. Care should be taken not to lose the screws. The center of the airplane tire has a huge central nut, very similar to a racing car's nut. Special tools are required to remove it. However, each tire weighs about 500 kilos. Special equipment is needed to assist. Just like that, the tire is easily removed. It seems effortless. Before installing the new tire, the mechanic also needs to check the wear of the brakes. Fortunately, the brake pads of this tire don't need replacement. You can install the new tire directly. Similarly, use equipment to align the new tire with the axle. Carefully install it, then put on the spacers and install the center nut. Another mechanic is needed to help screw the nut in. According to company regulations, the central nut must be tightened to 250 Newton meters. Then install the safety screws, put on the protective cover, lower the jack and let the tire touch the ground. The airplane tire replacement is then completed. 2 skilled mechanics can complete the job in about 15 minutes. The removed old tires can't be discarded. They need to be recorded and returned to the factory for refurbishment. Typically, each tire can be refurbished and used about 5 times. That's the process of changing an airplane tire. Did you learn it? Do you know how the underwater piers of the Golden Gate Bridge were built? Actually, before construction, bombs were used to blast a flat area on the seabed. However, how to blast is important. If you just throw a bomb on the seabed, most of the energy from the explosion would be absorbed by the water, and it won't have much impact on the seabed structure. To achieve the best effect, the bomb must be buried into the seabed. So how is the bomb placed inside? Since it's a timed bomb, timing is control. Divers might just place the bomb and it could explode. But a genius designer thought of a solution. Place a hollow explosive tube from the surface to the hole. After all the divers have left, the workers above can drop the bomb. With a huge explosion, a flat area was blasted out of the seabed, laying the foundation for the subsequent pier construction. But the divers' work wasn't done. They had to clean up the debris and silt from the explosion. With the help of heavy machinery, a perfect seabed was finally achieved. Now, prefabricated steel structures can be installed. However, in those days, Scuba tanks weren't invented, so divers breathed through long tubes stretched from the surface. After 6 months of difficult assembly, the steel structure of the pier was finally complete. Now, wrap the steel structure with wooden boards and pour concrete inside. But there's a problem. When concrete mixes with rainwater, it will scatter everywhere. Don't panic. This can be solved with polymer-modified concrete and conduit laying. First, pour the concrete into the conduit. The conduit is connected to the crane. While the concrete is being transported, the conduit is also rising, reducing the chance of contact with water. Now, drain the water inside the pier. At this time, the foundation of the pier is not very firm. The pier needs to move down another 15 meters, ideally touching the solid bedrock. For this, a 15-meter thick reinforced concrete slab needs to be built inside. Because the seawater is extremely turbulent, the pier could collapse at any time. This concrete slab ensures safety and provides support. Now place several vertical shafts inside the pier. Workers can go down through the shafts under the concrete slab. They will dig out this 15-meter thick soft soil to prevent workers from being drowned by seawater. A pipe was specially designed to supply air to the chamber. When the internal pressure is greater than the outside, there won't be any seepage. As workers excavate, the pier also slowly descends. Once the workers completely clean it up, more steel structures can be added and fill the entire interior with concrete. The underwater pier was built in this way, but it's not over yet.